Morning everyone, my name is Bhavarishkar and today I am presenting padding and stride, an important topic in deep learning. Let's begin.
In CNN, filters are used to extract features like edges, corners, or textures from the images. But as we keep applying this filter, the image size or more accurately, the feature map keeps getting smaller. As you can see here, that here one is the input image, and there is the kernel that is filter we applied on that image. When we apply kernel on that input image, the output size reduces to 2 by 2. The input image of 3 by 3 size has reduced to 2 by 2, reducing its border features. So padding and stride plays important role in this. Padding helps to decide the size of the output. Padding and stride helps to decide the size of the output images. Let's see what exactly padding is. So padding means adding extra pixels around the image boundary. It prevents shrinking the feature maps after every convolutional layer. So what we do is we apply some extra pixels, usually zeros, around the image. As shown in this input image, we have applied the 0 pixels on the border of the image. So when we apply the kernel on that image, the output size becomes same as the input size. That's how the padding works. So there are two types of padding, valid padding and sem padding. Valid padding means no padding. The input image, the kernel applied on the input image with no padding, and the sem padding means 0 padding. We apply 0 out at the outer border of the image. So the remaining the output of the input image after applying the kernel remains same. Next, it's stride. The stride is the number of pixels the filter moves slides over the input image. As we know, the kernel moves through the image. So when we so stride decides how many pixels the kernel can be moved. So stride 1 means filter moves 1 pixel at a time, and stride 2 means filter skips every alternate pixels. As you can see, the given example or the image, the kernel has moved 2 pixels. First, it is applied on all the 0 corners over here, and it moved directly to 2 pixels, and it has gone to here. That's how stride works. Let's see how. So in convolutional operation, the filter matrix moves across the input image by step by the step defined by stride. If padding is applied, zeros are added around the border before this operation. The output size is given by f minus n plus 2p divided by s plus 1, where n defines input size, f defines filter size, that is kernel size, p defines padding, and s defines stride. So padding ensures border pixels contribute to the output, and stride defines how densely features are sampled. For example, if a 5 by 5 image with a 3 by 3 filter, a stride of 1 and padding equals to 1, then the output size we can calculate using the formula f minus n plus 2p divided by s plus 1. Next, here you can see the example. The image is of 4 by 4 size here. This is the image, actual image, and the 0 pixels are the padding. So when we apply the filter on this input image, including padding, the output we get is the 4 by 4 image, same as the input size. So that is the importance of padding and stride in an convolutional operation. So what are the challenges? However, using too much padding can add artificial borders which may confuse the models. On the other hand, using a very high stride might skip important features and cause important information loss. So it's all about balance, choosing values that suits the network purpose. It also includes the computational complexity when we apply large filters and paddings. Next, to summarize this, padding helps preserve age details and maintain output size, and stride controls how much the filter moves and affects the size of the output. Together, they make CNN efficient and accurate. Famous models like LeanNet, AlexNet, and ResNet use same padding with stride 1 or 2 for optimal performance. Thank you for listening.